Topic of my talk today is the future of sustainable black pigments, and this is a topic that's very near and dear to my heart. Not only are we producing these type of pigments, but also I want to be a good steward to the environment, and that's sort of the essence of this talk itself. From an agenda standpoint, I like to talk about sustainability, and that word came up quite a bit today, so I may not have to go through all those details. It seems like the audience here is pretty well familiar with that term. But look at some of the targets that each of our companies are at least promising to deliver. The next, since we're talking about the future of black pigments, we have to talk about what is currently used. So carbon black is sort of the status quo. I know in an earlier talk from Nippon, they stated that this product is an evil product. I wouldn't necessarily go that far, but certainly in certain applications, it is worse than some of the other alternatives. Separate from that talk, we're taking sort of a different path to find perhaps an alternative to use instead of the traditional carbon blacks that have been used. We'll spend a lot of time talking about that type of technology. So the biorenewable black pigment itself, looking at the production process itself, how it's made, how it deviates versus the traditional carbon black process. Take a look at feedstocks. We talk about biorenewable material. That's certainly one of the first questions that gets asked. And then really spend a lot of time looking at the performance. This product itself is an alternative to carbon black. I wouldn't necessarily say it's a direct replacement, so swapping out one for one probably isn't ideal, but certainly for new stylings, this could be used as a wonderful new styling tool. At the end, I'd like to go through some of the benefits for the coating industry of this type of product. So let's jump into it. Sun Chemical, much like the companies that you represent, have really embraced sustainability over the last decade or so. We have larger groups of people globally tasked with looking at this, sustainability managers, and the Focus Conference a few years ago had, I think, one of the keynote speakers from PPG talking about their sustainability efforts. And Sun Chemical certainly is taking the approach to using sustainability to guide the way we develop, manufacture, and distribute our products. We've also made some bold statements, like many of our companies have, looking at carbon neutrality, reaching that by the year 2050. These are wonderful words and sentiments. The big challenge is how do we get there, right? There has to be some fundamental changes on how we operate our business. You can certainly looking at renewable materials, utilizing green energy to help in this regard. But the reality is that we need some really big scientific advancements to be able to achieve carbon neutrality by 2050 or whatever date that your company has put through. We do issue sustainability reports to sort of document our progress, and I think that as an industry, we all understand that this is the right path forward. The question is, how do we get there? One of the helpful aids, I think, in this process, the UN established these Sustainable Development Goals in the year 2015. And the idea was to have sort of these 17 type goals serve as guidelines to help end poverty, help protect the environment, and also ensure future prosperity. I don't think we've ended poverty yet, but I think these certainly are pushing us into the right direction. And if you look at some of these 17 goals, a couple certainly resonate with me. Number 9, industry, innovation, and infrastructure. Number 11, sustainable cities and communities. 12, responsible consumption and production. And 13, climate action, clearly have an impact on product sustainability, carbon footprint, things of that nature. And we utilize these goals in our sustainability reports. In my research for many of the companies that are out there, whether it's a paint manufacturing company or an OEM, you see some elements of these UN Sustainable Development Goals, and it helps sort of align sort of our approach so we speak the same language. One of the challenges with sustainability is always words versus details, right? So I think in this talk, I'll go through some of the marketing type positions, but then also include enough data to really justify that it's not greenwashing, that it truly is a sustainable product to consider. Carbon blacks themselves, I did a look at the name tags out front. I was happy that I didn't identify any carbon black manufacturers, so I won't be, no sticks or stones will be thrown at me. In general, there are a few different ways to produce these materials. So the diagrams shown here are 3 of some major ones. So the upper left-hand corner, furnace black process, upper right-hand corner, the channel black, and the bottom, the thermal black process. Clearly, you see inputs into this processes, oil and gas. The exact opposite of a sustainable type raw material being used here. Not only that, but you see some flames, and it certainly indicates that you're burning some things, creating, putting in a lot of energy. So not only is the raw materials themselves not sustainable, but the process itself is very energy intensive, making this product, I wouldn't say evil, but not ideal if you're looking to meet some of your sustainable targets for your business. So I think there's an opportunity to have an alternative carbon black type product, so not shifting to a different chemistry, to reduce the overall environmental impact, provided there's some table stakes involved, right? The performance has to be acceptable. I'm not saying the performance has to be exactly the same, but certainly in the ballpark of acceptability to be used as a pigmentary form. Since you're dealing with sustainable products with biorenewable raw materials, how consistent is that product, the end product? Because there's certainly variables in some of the raw material sourcing. Can you make a consistent product lot to lot so that what you use today is the same as what you use in your automotive coating a year from now? Cost, I put third in the list. If there were some procurement people in the audience, they may have wanted that to be first in the list. But again, it has to be acceptable, right? As a company, Sun Chemical has developed in the past phthalo blue pigment that was 10 times, that was sustainable, a renewable-based phthalo blue was 10 times the cost of a regular phthalo blue. Certainly, we didn't bring that to the market because the cost just wasn't acceptable in that mix. This type of development, I think, does meet sort of that acceptable cost range. And the final part is availability. Think of all the applications that use carbon black, right? In the automotive industry itself, it's a really big volume product. And for us to have an alternative, you need it to be produced and available enough to sort of take on a big portion of that if your companies decide to go down that path to select that product as a more sustainable one. Looking at the biorenewable sources that are at hand, the biggest opportunity I think we sort of settled on come from this Sustainable Forest Initiative, this SFI. And that includes areas of slash piles from lumbering and mill residue. So this is material that would have been harvested from the forest, used for wood applications, and this is residual waste that would have gone to a landfill. That is clearly where we've settled on in terms of the core raw materials that we're looking at as a feedstock for this process. There are other sources of other material that are diverted, that could be diverted from landfills. We've explored those areas, but we found that the SFI Forestry Initiative was the best. Some of those other diverted materials have some connection with food processing, and we really didn't want to sort of be connected or have anyone think that we're disrupting sort of the amount of food that's available for human consumption. How is this process better than the carbon black process? What essentially is being done is you're taking that waste lumber, that waste wood material, and creating a biorenewable crude, a char material. So you're burning that to create sort of this charcoal type product. In that process itself, you create that biochar. You also create syngas. That syngas can be utilized back into the system to continue the production or maintain that production level, and at the same time produce some level of electricity. There is a little bit, for full disclosure, a little bit of carbon or natural gas that's used for plant startup, but once this process starts, it essentially is self-sufficient. The syngas that's generated gets burned into to create more and more of the material. It's been certified, so Pure Earth is a certification company that they certified the carbon capture, that 1 ton of this biochar or biorenewable crude produces 2.8 tons of carbon offset. And that is, in essence, where we get the sustainable benefit. From the raw material that's being chosen to create this charcoal type material, that's the carbon negative that we carry forward. We don't add so much to it to shift it away from being a carbon negative type product. A little bit more on the Sustainable Forest Initiative. The material that we're sourcing for this type of product comes from the Pacific Northwest under the SFI type standards. And if you look at the sort of the small print, sort of at the bottom, it gives a little bit more detail. The standards for that SFI forestry include conservation of wildlife and water, climate-smart forestry, as well as support the relationship building with indigenous people of that area. So not only is it a product that has a carbon negative nature, but it also is sort of supporting an initiative in the market that really protects some cultural aspects and really is a win-win, I think, for all involved. So in essence, we're taking material that has carbon capture from the lumber stream, something that would have already been discarded. That waste material gets processed into that charcoal type product. We take that charcoal product in its biochar form and with milling processes that are well established in our company, create a pigmentary black form that can be used into automotive applications as well as industrial plastics and what have you. The benefit is that carbon capture in the initial point and that the various steps along this process chain that we're not adding too much energy or CO2 emissions to offset that. So you're taking that bio-based material and creating an upcycled black product. There's a couple ways to look at that from a calculation standpoint. On the left-hand side, we're taking consideration the benefit of the carbon capture from the biochar material itself. Let me go back. On the left-hand side, below this line, showing that it's a carbon negative. So the biorenewable growth, you're capturing all that carbon. You certainly create a starting point that you're negative in terms of the CO2 contribution. The added input of milling adds a small amount of CO2 back in the system. The overall net is still on the negative side, right? In milling, we know that there's going to be processing steps that add to the CO2 emissions, but we're very happy to be still on the negative side. If you just look at the production of that biorenewable black from our perspective, so you still have that same height in terms of the CO2 emissions coming from our production itself versus carbon black traditional production, it's night and day, right? So no matter how you slice it, you see the benefits not only of using the certain raw material, but also from a processing standpoint, much less intensive in terms of creating CO2 emissions that are out there. So renewable black, the performance. In general, the product obviously is a black. We wouldn't have called it that if it wasn't. You see on the top bar here a series of 3 different swatches. The one on the left is the biorenewable material at a 0.05 pigment weight concentration. In the middle is the carbon black at the same pigment weight concentration. And then you have the biorenewable black at a pigment weight concentration 3 times the amount. All of those are black, depending on the how calibrated the monitor and the screen is. You see some varying levels of darkness. So in essence, I think what you've established with this biorenewable material is that it has a decent level of blackness, right, of black hue in that mix in the mass tone. In some areas, you see slightly brown undertones in the mass tone itself. In the tint, which is shown at the bottom here, again, those same type of pigment weight concentrations in combination with a TiO2, you see some variation in terms of the color. And that's coming from the color strength. As a full disclosure, the biorenewable black does have a lower color strength, about 50% or more. So it is lower in strength compared to carbon black. So again, I highlight that as a direct replacement, depending on the styling, you may or may not be able to swap out one for the other to achieve that the coloration you currently have. What you do have is the ability to leverage some of the unique values of this product. Looking at in the white reduction, you see more of a blue undertone. And when we had shown this to some of the designers in the industry, they thought that was a useful tool, right? Something that gave them a different look than the traditional carbon black. So not only are we looking at what is currently being done, but we talk about the future of black pigments, this gives a future tool to help the designers to create stylings of the future. Alongside with having a lower color strength, you would imagine there's a difference in particle size, and that's certainly the case. These high chromocarbon blacks are traditionally small in particle size. Here we're on the order of 100 to 200 nanometer range. And as a result, not only is the tint strength lower, but you would also have a lower jetness. And this is just an example from an earlier study looking at the jetness values. So MC and MY are a level of jetness in a product. The higher those values, the more jet, the more extreme, the dark shade. And in essence, we're about 20 units lower in jetness. So if you have a styling looking for try and match a piano black type styling, this biorenewable black probably isn't the right choice. If you have a dark gray, I think there's opportunities there, and all colors beyond that. But I think there is certainly a caveat for these really dark black shades. Carbon black still is the go-to. For all others, I think this biorenewable black can be a useful product of interest. So larger particle size leads to lower tint strength and lower jetness. Where I think having a larger particle size is helpful is in terms of durability. So we are conducting our 2-year Florida now, some accelerated weathering and early indications that we are comparable, if not slightly better, from a durability standpoint. But I don't think carbon black is a problem product for durability, so I think it's sort of a wash at that point. We did some testing in 2 different systems, so it's important to look at it in a waterborne and solvent-borne system. The first set of data is in the waterborne side. On the left-hand side, you see 2 panels in a mass tone. Here we have 4% loading of pigment. Essentially, you see 2 black shades. If you look closer on the monitor here, you do see a little bit of a darker shade with the pigment black 7. Looking at the chart itself, so we're looking at an A versus B color chart. The A value, the further to the left, the greener the product it looks, further to the right, the redder. On the y-axis, the B value, the higher it is, the yellower, the lower it is, the bluer. The biorenewable black shows up as a little bit bluer compared to carbon black. Carbon black does show to be a little bit greener. I think that's part and parcel of the giving you that jetter appearance. Not surprising when we look at the jetness comparison. It dovetails with the original information that we'd shared, that there's about a 20-unit difference between the biorenewable black and the carbon black. So both the MY and MC values of the biorenewable black on the order of 230, 235, and that jumps up to 250 on the carbon black. Again, for jet black stylings, I think you still would need the carbon black. All others, you can still utilize the lower jetness version. In a white reduction, here we've combined that with titanium dioxide in a ratio of 1 to 9. You start seeing more of a discrepancy in the panels, the photos of the panels themselves. From a color space standpoint, you have the biorenewable black, slightly bluer and considerably more green compared to the pigment black 7. And that sort of correlates with the earlier swatches that we had seen for the styling. And the third reduction we have is an aluminum reduction. So black pigments are used often in metallic stylings. So we use this to showcase how it looks in an aluminum reduction. 70 parts of pigment, 30 parts of aluminum. And here what we see is a unique color and a unique color travel. So we're measuring on that same color chart, A and B value, looking at multi-angle curves, so how that part looks as face angles versus the downflop. Carbon black starts out at those face viewing angles of minus 15 degree, very yellow at that face viewing angle, right? As you go down the color travel, as you look at that panel or that part at different angles, it drops from a yellowness of around 10 units on down to 2 units. So a significant amount of hue travel, right? 10 to 2, 8 units is quite noticeable in this metallic styling. And I think when we get to the solvent board side, you'll see the sort of the panel, what the panel looks like. I didn't have a panel photo for this one, so I apologize. So you have a significant amount of color travel. What is unique about the biorenewable black is that it doesn't have a similar travel. If anything, it stays very neutral in its hue. I think that creates an opportunity, perhaps, for some new stylings, staying bluer and not that yellower tone, right? Not to say that yellower, that warmer look is bad, but having something different in the hands of designers, I think, is certainly worthwhile. Next, take a look at the solvent-borne system, and you won't be surprised, but you'll have similar results here. The panels themselves are obviously different panels. There's some light effects at the top here in terms of taking the photos of these black panels. But here we've taken an added step to showcase not only just one lot of the biorenewable black, but several different production trials. The idea here is to showcase that with different raw material inputs, right, different lots of raw materials coming in, that we can process that charcoal material into pigmentary form in such a way that we have a very consistent end product, right? So this is 4 lots in a production scale, so I think it's a good indication. I think further work's needed, looking at perhaps a year difference between the feedstocks as you're deriving something from a lumber stream. Perhaps arid conditions or drought conditions, whatever, could have an impact. I think that remains to be seen. But early indications, fairly consistent, right? All of these dots very close together. If you're splitting hairs, you'd say that the carbon black is slightly bluer than these other ones, but those other 4 lots are surprisingly close. I mean, I was surprised seeing how consistent that data was, pleasantly surprised. Just for instance, from a variability standpoint, as a pigment supplier, we traditionally endorse our pigments plus or minus 1 unit in terms of these color spaces, right? If anything, we are 0.2 of a unit different in each of these lots, so a wonderful result. Taking a look at the jetness, here we see a little bit of a different story than we had with the waterborne. That 20 delta unit jetness difference is much less in this case, right? So we're on the 220 to 225, maybe a 5 unit difference. I myself, for full disclosure, I wanted to put this data in this set. I do think that there are some measurement application challenges with measuring jetness that I think is at play here. And I don't want you guys to get the wrong idea that we're in solvent-borne that much closer in jetness. I still think that we are in that 20 delta unit difference. But we have the data set. For full disclosure, I share everything just to be open and honest. In that white reduction styling, again, we have a similar story, right? So we're in a white reduction. We have carbon black being slightly on the yellower side. It's still blue, -3, but not as blue as the cluster of all these production lots in this mix here. So not only is it bluer, but it's greener. And you see that in the panels on the left-hand side. So it is a different look, right? I think you can certainly leverage that in different ways, but certainly I think it's fairly consistent from a production standpoint, which is a great sign. Aluminum reduction, and this is what I mentioned before, sort of a different appearance in this aluminum styling. So this, I'm not saying it's bad, but it does have a yellower tone to it, right? I think a warmer look, and sometimes a brown or yellow seems dirtier to some people's eyes, and a cleaner, cooler appearance with the biorenewable black, again, gives another option. A similar type color travel for carbon black is shown in the solvent-borne application. So starting out very yellow down to a bluer shade. What's nice to see is that not only does the trend itself, but also the magnitude in the application of the carbon black curve really matches up with each other. Same is true for all of the different production lots here, showcasing that minimal color travel, always on the bluer side. So I think from a color space standpoint, this is, I think, a unique area, at least the feedback we've gotten so far, and that was the case. Despite limitations with those high jet colors, piano black and the like, there's some broad color spaces that can be achieved. In our last color styling show, we created a few shades utilizing this biorenewable black. The first was this styling in the lower right-hand corner, a very dark gray. So that's the biorenewable black with some aluminum, a small amount of indanthrone, so a red shade blue, and a little bit of an effect pigment, showcasing that you can create a very dark shade, right? While achromatics are very popular, over 80% of the stylings are in that color space. Blacks are a portion of that, but there's still a number of dark grays and grays that are sort of can be achieved with this type of product. On the flip side, we have a lighter gray styling where it's a higher loading level of aluminum along with the biorenewable black and a little bit of an effect pigment, showcasing the breadth of dark to light. What I think is amazing or very cool is that we're in leveraging the blue tint. If you combine this in a very simple formulation, so it's 85 parts of the biorenewable black, 15 parts of a high chroma mica, that you can create a very rich, vibrant blue. So you're leveraging that blue undertone in a styling that really resonates with that, right? If you put it in a yellow, that blue undertone actually hurts the chroma, but in this blue color space, I think it's ideal, right? And it's pretty amazing that you can achieve that kind of color. All three of these panels are at our exhibit, so during the cocktail hour, certainly stop on by with your adult beverage and take a look. In terms of benefits for the coating industry, I promised that we would have some data, right? So the earlier chart looking at CO2 emissions was more just columns. Here we're getting into the nitty-gritty, actual numbers that we have. So we've done a lot of work working with our raw material suppliers to assess the CO2 input from their process, and also taking a look at what we do on our end. So the top portion is the CO2 emissions from the raw material. So the biggest portion is that CO2 uptake. So using that material, that carbon that's already been contained in the wood itself, you have a 7.5 CO2 equivalent. There is some processing on their end, so there's some biogenic CO2, fossil, the other greenhouse gases that sort of cut into that overall negative carbon number, and the end result is just a shade under 3 in terms of negative carbon value. On our side, we're adding just a small amount, right? Purposely, we're trying to run our process with the minimal amount of CO2 emissions, and to the order of 0.13, which is really shocking when you look at some of our other processes that would be much higher to make a perylene or quinacridone or whatever. This is a wonderful target. The way we've achieved that is by utilizing not only smart, efficient milling processes, but also green energy at that production site. So that was something that we selected that site purposely for that reason, to have as far the best CO2 equivalent we could possibly get. The end result is a calculated cradle to gate of -8 or 2.84 for our product going to out the door to the paint customers. Now, certainly you would have to add your own processing on your end, whether it maintains that negative value in the overall paint formulation going out, but certainly getting to you guys, you're in that negative range. For comparison, if you look at the sort of the estimated product carbon footprint of carbon black, we're almost on the exact opposite side, on the positive side. So between this positive 2.4 to minus 2.8, that 5 unit kilogram equivalent is certainly a lot of potential savings, right? And it helps not only us reach our goals or move towards our goals for carbon neutrality, but hopefully the industry itself can leverage this type of new product as a way to utilize those offsets to help out the overall performance. So some interesting stuff. In essence, we're taking a product that would have been a waste product from the lumber stream and turning it into a new raw material, right? So you look at assessing that product, utilizing its carbon negative nature, targeting a production area that has a green energy. So we're doing everything we can to make this as more carbon negative as possible. We are providing this data as cradle to gate. As we finalize our production process, we will do the due diligence for a life cycle analysis and have third-party certification so that we can quantify to make sure that this number is exactly where we're at. So I think there's some further detail work that's needed to really hone in on the numbers that we have. We're calling this cradle to gate because our end customers could use this in a variety of ways, right? So it could be used in an automotive area, could be plastics, could be inks, could be printing and packaging. So we are only in control of as it leaves our gate. So the rest, I guess, is up to you to take a look at how your processes would be impacting the overall CO2 equivalent of that product. But clearly you're avoiding that carbon avoidance by having that CO2 captured from the get-go. And I mentioned the life cycle analysis that would take place. In terms of sort of the CO2 management, you have reuse, reduce, renew, recycle, redesign. We're really focusing on 3 different R's. So the reduce the CO2, so having a raw material that reduces the overall amount of CO2 product carbon footprint itself, and then managing the process on our side. In terms of renew and redesign, really taking a look at how we produce our products. So we don't necessarily produce carbon black. Now we're involved with biorenewable black. We have functional black pigments. But how do we want to redesign our dispersions based on this, right? How we do a lot of, we have an inks business, how we want to investigate and how can we utilize maybe this type of product for our own internal processing for other application areas. And I think a lot of the customers would also take a look at a redesign on how you're doing current formulations or looking at things for the future. And then in terms of the utilizing renewable materials, I think is always a great path forward, especially one that has the availability, has the consistency that we have identified here. And I think in general, we look at developing new products. This is a first step, right? So certainly as a gambler, Sun Chemical is betting on black to be successful. But we're also holding out their development to bet on blue, to bet on green, to bet on red. Those, I think, are hopefully to come, but at least we're making one step forward. So I thank you for your time today and your attention. I'd love to hear any questions you may have.
All right. Yeah. Okay.
With the larger particle size, I guess, of the biorenewable black compared to traditional carbon blacks, is it easier to disperse?
It is. The material itself is more porous, so you have to sort of wet out, take a little bit more concern in wetting that material out, especially in waterborne applications, just to make sure you have any air entrapment leaves the system. But in general, from a dispersion standpoint, a larger particle size, it's certainly easier to process through. Yep.
Just follow up on that, there's a question about the dispersion choice. The conventional dispersion works for carbon black, also works for this?
So far, it has, right? I'm sure there's other experts on the additive side. I see, is Tony Moore still here? He was in earlier. But I think that perhaps some experts on the additive side may be able to find something that's better. All our testing's been done with the exact same dispersants, right? So we haven't seen a need to use something different.
How about the settling behavior? Since the particle size are larger, are they as stable as carbon black?
We have not seen any negatives, but we also have not produced large batches or like large paint batches to see, right? So we're producing the pigment itself. We're putting in testing and lab scale test. I think the true rubber hits the road is when you have a larger batch, whether you see settling or not. We haven't seen it in our laboratory testing, but that doesn't mean in a larger scale that it wouldn't be a problem. But I think those things can be addressed with anti-settling agents. Just a matter of selecting the right one. But good question, Jalen.
There was also a question about the consistency of the product. Since you are using different source of bio-based material, can you comment on how to guarantee the product is consistent?
Most definitely. I think on the solvent-borne data, we showed 4 different production lots with different raw material batches. So I think that does indicate that we can make a consistent product. I do want to continue that, looking at totally different sourcing from different seasons of the lumber, just to make sure that we don't see anything that's different. But so far, the consistency is there using different raw material sources. I think as you make that charcoal type material, I think once you get to that point, I think you're fairly decent. The one thing that we have seen some differences lot to lot in terms of the ions that are in that char material, some levels higher than others. We haven't seen that be a negative in terms of paint application, but I'm not saying it's impossible. We're still sort of learning as we go. From a commercialization standpoint, we hope to have this commercialized perhaps May, June, so coming really soon. I know we talked to a number of companies over the years, and people are eager to get their hands on the final product, and I think we're getting there, right?
Okay, thank you. Any other questions from the audience? If not, there's another question on the app. It's about abrasion resistance between the bio-based black versus carbon black. Can you comment on that?
I can't say for certain. I don't know if we've looked at the abrasion resistance of this product. It's something I can follow up with. That was on the Hove app, so I can respond back to that person. Okay.
Okay,